All right, students, here we are. We are going to talk about ratios for a minute before we jump into Chapter 5. Chapter 5 is all about ratios, but I want to give you a quick reminder about what we talked about in Chapter 4. In Chapter 4, we talked about ratios and the fact that they're comparing two quantities. We talked about rates and unit rates as well, so if that's something you don't quite remember or you didn't pick up on in class, go back and check some of Chapter 4 videos to just verify or remind yourself of what those were. All right, here we go. One thing we need to know for the lesson that we are about to encounter is that there are many different ways to represent ratios in words or in talking. We know that we have the ways to represent this, and we talked about it in class, where we would write 2, 5 like this, or 2:5, or we would write it as a fraction. And we would have to take it from the word format and put it in one of these. However, we didn't necessarily write in our notes or focus on all the different ways that we could see what it means to be ratios in word form. So I just want to let you know that if we talk about having 15 out of every 45, we're talking about 15 out of 45. And this is going to be critical because today's lesson is trying to take these ratios and put them into percent. And in order to put them into percent, we have to be able to compare them in a proportion. And that'll make sense in a minute. The other way we have is for every. 17 for every 20. 17 for every 20. For every is another way we can write a ratio. Out of 21 out of 100. This is often what we talk about when we talk about our tests. I got 21 out of 100. I got 17 out of 20. I got out of. So these are just another way to write those. And this is just another way to state this one. For every 21, there are 83. So just kind of keep those in mind as we go through some of our slides today. All right, percent. What I want you to know is this word here, percent, and the specific word cent. I want you to think about the word cent as in money, century, centennial. They all have to deal with 100. Bicentennial would be 2 100s. But they all have to deal with 100. Cent, century, that's its root word. So we're talking about per, we're talking about part of. What part of 100 do we have? That's what percent means. What part of 100 do we have? So out of, again, here's our ratio word, out of 100. So what we have to do today is take all the ratios that we know and we need to write them in a percent. Well, think about taking a test. What's the best score on a test you can get? 100. Unless you get extra credit, but don't worry about that. So 100 is the best score that we can get on a test. So let's just make that our focus for right now. In a recent census, 26 out of every 100 people living in Illinois were younger than 18. Here's our key word right here, out of every. So right now, I'm just going to quick write a ratio here, and I'm going to write it in fraction form. Really the form we'll focus on now. 26 out of 100 people living in Illinois were younger than 18. So I know that this group is younger than 18. What percent, that's what I'm trying to find, of people are younger than 18? So all of this goes together right here. I know my best percent is 100%. So remember we talked about in class is we wanted percent over 100. What percent are we going to find over 100? Well, we know that 26 out of 100 was how many people are younger than 18. Now when I'm comparing this, well, this one's super easy. How do I go from 100 to 100? Times 1. How do I go from 26 over here to where x would be then? Times 1. So what does x equal? X equals 26. Let's say for some reason you did not see that method. Go ahead and set it up to solve algebraically. 100x would be on this side because I cross multiply. 2600 would be on this side, and I still have the equal to sign in between. So it's 2600 equals 100x. I am going to solve for x. It's being bothered by the 100 by multiplying, so the inverse is to divide by 100. I'm going to divide. Those will just end up canceling, and I will be left with 26 equals x. And that's the same answer we found here. Remember, we were looking for a percent though, so I know that the percent of people who were younger than 18 is 26%. That goes with question 1. Let's talk about question 2 for a second then. For question 2, it wants to know how many people, or what percent of people were older than 18. Older than 18. Well, if my best percent is 100 and 26% of them are younger than 18, that means the leftover percent is older than 18. So if I take 100 and subtract 26, I'll get my leftover percent of 74, and you can double check my math. But if I just subtracted those, I'd have 74% would be older than 18, and that would add up to be my total 100. All right, let's look at this next one. At a local middle school, 140 students take Spanish for every 100 students who take French. All right, so we have 140 for every 100. So what percent of the students take French? This question here at the end isn't necessarily written correctly, but really we just want to find the percent here. So I'm going to kind of cross this part out because that's a little bit deceiving. And I want to know, what percent is this? How many students take French compared to take Spanish? Well, again, my best percent is 100%. And how am I going to do this? I'm just going to multiply by 1. So 140%. Now that seems kind of weird to say. I thought 100 was our best percent, but this just is telling us that more students take French than Spanish. And let's make a list here. If I was to make a table of Spanish and French, and you don't have to do this, but I'm just going to show you quick. If I had 100 students taking Spanish, I'd have 140 taking French. If I had 200 taking Spanish, I'd have 280 taking French. It's just showing me that whatever I have here, it's going to be 140% more taking it over here. It's going to be more than that. I did my math wrong here. But it's going to be more than that. So you just have to be careful. No, I did not. Okay, sorry about that. All right, so next question. Dan Marino, in his football career, Dan Marino completed a pass about 59 times out of every, here we are again, 59 out of every 100. Again, this is super easy because it's out of 100. He completed, so this says, what is his percent for completed? Well, I know these are his completed, so it's already over 100. It would be 59%. About 1 out of every, here it is again. About 1 out of every 10 Native Americans in the United States are part of a Cherokee Nation. What percent is this? 1 out of 10. All right, suddenly we have a problem. It doesn't equal 100. We know the best percent that we want to attain is a 100. So I want to know, what percent over 100 is this? So I can solve this in 2 ways. One way, because this denominator is a factor of 100, is I can multiply it by 10, and I could find out that 1 times 10 is 10, 10 times 10 is 100, so this would be 10%, because this would be my 10% over 100. The other method that I could take, does yellow show up? Yep. The other method I could take is if I had 1/10 equals percent over 100, is I would be able to cross multiply. Let's see if I can make that go away. 10 times, let's say this was x, would be 10x. This would be 100. So I would have 100 equals 10x, divide both sides by 10, and I would find out again that the percent on top, my x, would equal 10, so 10%. All right, another one written a little bit differently from what we have seen. Let's try to change up some colors here. Yes, we can see that. All right, about 1 out of every 200, about 1/200th, remember a fraction is just another way to write a ratio. About 1/200th of the toys were defective. And this could also be said as 1 out of every 200. That's how we wrote it. What percent of the toys are defective? They just gave it to us in the fraction form, and we want to know x percent over 100. What is this over 100? I could divide by 2, but it's going to give me some really, some numbers that could possibly cause me to make a mistake. So I'm just going to go this route. 200 times x is 200x. And this would be 100. 100 equals 200x. I'm going to divide both sides by 200. These will cancel out, leaving me with 1/2. 1/2 equals x. So you have to ask yourself a question. What was I solving for? X percent. X percent. So 1/2 equals x 0.5%. Don't move a decimal. Don't do anything. 0.5% is how often the toys are defective. 0.5% of the toys are defective. How many are not defective? How many toys are not defective? So now here I'm just talking toys. I'm not talking percent. If 1 is defective, 199 are not defective. What percent of the toys are this? Well, I could either set up a new proportion, or I could just subtract this from 100 and get 99.5%. So, depends on how you want to look at that. Those are two ways to solve that. I'm running short on time here before the computer won't let me record anymore, so I'm sorry if I'm rushing through the last few here, but let's see what we can do. Almost 3/4 of the people who travel buy tickets online. So I know 3/4 buy online, 3 out of every 4. What percent of people buy their tickets at the counter? Ah, be careful what you're reading here. They changed it up on us. If 3 out of every 4 buy online, that must mean 1 out of every 4, because I want it to total 4. 3 out of every 4 buy online, which means 1 out of every 4 buy at the counter. Then I need to know what percent is this. So I want to set it equal to 100. Solve it how you like. Do proportion, or in this case, 4 goes into 100 nicely with a 25. So I know I can just multiply both of these by 25. 1 times 25 is 25. 4 times 25 is 100. But now that 25 is in the x spot, so I know it would be 25%. Some of you may have known that right off from the beginning, right off the top, because you know 1/4 is 25. But in case you didn't, there's your math. Remember, pause at any time. All right, here's a few problems. Set them up as a proportion to solve. What percent over 100? So I can cross multiply. I'm just going to set all of these up, and then if I have an opportunity, I'm going to write all of the answers down below because I have 40 seconds left. 1 out of 500 equals what percent over 100? Feel free to pause this, solve them, and then unpause it to see if you got the correct answer. First one would be 70%. This would be 45%. And this one would be not 20%, 0.2%. So I'm trying to go quick. All right, sorry that I have to end this so quickly, but I hope that helped. Have a good day.